Okay, let's look at some graphs and see if we can pick out what the vertical and horizontal asymptotes are. So before we even get started on identifying where these are, I want you to first look at the scale on our axes. Notice that we get to 10 in 1, 2, 3, 4, 5 lines. And same thing here on the y-axis, 1, 2, 3, 4, 5 lines, we get to 10. That means that each of these lines is a 2. So we have x equal 2, 4, 6, 8, 10. Y, same thing, 2, 4, 6, 8, and then 10, which means the negatives for the y, -2, -4, -6, -8, -10. So you always need to make sure that you understand what's going on with the scale of your graph, because that is going to change the number values that we include. Now, the vertical asymptotes are normally the nicest ones to find because your function is just skyrocketing up or plummeting down, or both in this case. And it seems that they are doing this right around this dashed line, which means that we found a vertical asymptote. Since it's vertical asymptote, it's going to be an x equals, and then remember our scale. So it's not x equal to 1, it's x equal to -2. You have to have the x equals. If you just put -2, you're giving a number, not an equation of a line. And your asymptotes are actual lines. Let's see if there's a y asymptote or horizontal asymptote, which is going to be a y equals. So that's where our graph tends to flatten out or get really close to a number. So if you notice on the right-hand side, we start to flatten out where x is over by 10, and flatten out on the left where x is over by -10, but we're talking about horizontal asymptote. So we're flattening out. Dashed line for our asymptotes, it's horizontal, so that's a y. Notice that it is halfway in between the two lines, or halfway in between the box. So it's going to be a 1, but since it's below the x-axis, it's going to be a -1. So our horizontal asymptote is y equal to -1. Let's try another one. We're going to look at our graph, and if we're looking for vertical asymptotes, we're looking where our graph skyrockets up or drops down to the ground. And if you notice, working from left to right, there are two different breaks in our graph where one side just plummets to the ground while the other side goes up, which means that we are going to have two separate vertical asymptotes. The first break in our graph where one side goes down and the other side goes up is at our first dashed line. Remember, asymptotes are dashed. Since it is a vertical line, it's an x equals, and it's going through the x-axis at x equal to -3, because this time our scale is going by ones, which means our vertical asymptote, our first one, is x equal to -3. Looking at our other side, the second break in our graph, we do have another instance where it drops down to the ground and explodes up into the sky. And this time the value is x equal to 2 because it's crossing through 2 on the x-axis. So our two vertical asymptotes are x equal to -3 and x equal to 2. We need to find if we have any horizontal asymptotes. Remember, horizontal asymptotes are when our graph flattens out. It's like the x values keep going, but the y value doesn't change. And because we have three parts to this graph, we can actually touch or cross over the horizontal asymptote. But remember, you never cross over the vertical asymptotes. So if we're looking for our horizontal asymptote, when we go on the left-hand side, it looks like we're getting really, really close to the x-axis. And if we go on the right-hand side, we're getting really close to the x-axis. And if you notice in the middle here, it flattens out the closer to the x-axis that you get. Seems to get really close to it, and then it explodes down to the ground again. This is our horizontal asymptote, which is going to be a y equals. And this is the x-axis, so that's where y is equal to 0. So we have our horizontal asymptote of y equal to 0. Notice that we had two vertical asymptotes, but we only had one horizontal asymptote. You can have all kinds of vertical asymptotes, but you will only have one horizontal asymptote if it exists.